Consider this problem in analytic function construction by using Milne Thompson method. Determine the analytic function f of z equal to u plus iv such that u minus v equal to e power x into cos y minus sin y with f of 0 equal to 1. So, first we have to identify this u minus v is a real part or imaginary part. For that, we are considering f of z equal to u plus iv. Take I times f of z, that will give you iu minus v. Then by adding equation 1 and 2, you will get 1 plus I times f of z equal to u minus v plus I into u plus v. Now you can observe that by labeling like 1 plus I into f of z as capital F of z and u minus v as capital U, u plus v as capital V, we will get the problem given here u minus v as the real part of capital F of z. The real part of capital F of z. If the real part of capital F of z given, you have to consider the analytic function by making use of Milne Thompson method formula accordingly. So before that, you have to find out the first order partial derivative of capital U with respect to x and first order partial derivative of capital U with respect to y. Then take x equal to z and y equal to 0. So first step is finding dou u by dou x. What is the function given? Here it is e power x into cos y minus sin y. So differentiation of u, this is capital U. With respect to x, you will get only one term is having e power x, that is x term. So differentiation of e power x with respect to x is e power x itself into cos y minus sin y. Then differentiating u with respect to y partially, you will get cos y differentiation is minus sin y differentiation is cos y. So minus sin y minus cos y into e power x. Now you have to consider x equal to z and y equal to 0. So taking x equal to z and y equal to 0, you will get ux of z comma 0, that is put y equal to 0 here, cos 0 is 1, sin 0 is 0. So e power z, put x equal to z. Likewise here, sin 0 will give you 0. So therefore, minus of e power z into 1. Now you are going to substitute in the formula. So what is the formula? Integral of f of z equal to ux of z comma 0 into dz minus I into uy of z comma 0 into dz. So this is, here we have taken it as integral of f dash of z into dz, that is nothing but f of z. So f of z equal to e power z integration with respect to z minus I into integral of minus e power z into dz. So integration of e power z is e power z itself. Therefore, you are going to have 1 plus I into e power z plus integral constant c. Now we know that capital F of z is 1 plus I into small f of z. Therefore, 1 plus I into small f of z equal to 1 plus I into e power z, because integration of e power z, we know that it is equal to e power z itself plus integral constant. Now, keeping f of z alone this side, you have to bring this 1 plus I to the right hand side. So, e power z into 1 plus I divided by 1 plus I plus c by 1 plus I. So, take e power z, these two gets cancelled, plus capital C dash. So, here they have given the condition f of 0 equal to 1. By substituting that z equal to 0, okay, given f of 0 equal to 1. Therefore, what you will get? F of 0 equal to e power, put z equal to 0, e power 0 plus c dash equal to 1. So you are going to have c dash equal to 1 minus 1, which gives you 0. So by making use of these conditions, we can able to find out the value of the constant c dash equal to 0. Now, substituting c dash equal to 0, you will get f of z equal to e power z into, okay, e power z, that's all. Here, from this equation, you are going to write, let us take it as this as equation 3. So, from equation 3, we are getting f of z equal to c dash is going to be 0, e power z itself. Hence, the analytic function is e power z. So, by making use of the condition, you have to find out the value of the constant in this manner. Now, we will move on to the next problem. This problem also we are going to do it in a similar manner. Consider this example. Find an analytic function f of z equal to u plus iv, given that 2u plus 3v equal to sin 2x divided by cos hyperbolic 2y plus cos 2x. Here, how to do this problem? We first have to identify that this 2u plus 3v comes under real part or imaginary part. So, for that, we are going to take 3 times of f of z equal to 3u plus I into 3v. Then multiply this f of z with 2i. You will get 2 times I into f of z equal to 2 times iu minus, okay, I square is minus 1, so minus 2v. Now call this equation as 1 and this equation as 2. Adding the equations 1 and 2, you will get 3 plus 2i into f of z equal to 3u minus 2v, separating the real and imaginary part, plus I times 2u plus 3v. So it is our choice to take, okay, whether if you are multiplying this f of z by 2, you may get, instead of like this, here we got it as imaginary part. If you are multiplying it by 2, you may get it as a real part. So, option is in our hand. By seeing this problem, you have to multiply it with f of z with constant, okay, depends upon the problem given. So, you are having capital F of z equal to capital U plus I times capital V. Therefore, this problem is an imaginary part of capital F of z. Now, all the other procedures are same only. First, you have to find out dou v by dou x and dou v by dou y. To find dou v by dou x, here the numerator is also a function of x, denominator is also a function of x. Therefore, using the division rule, you will get, okay, here you are considering this as u by v formula, which is going to be v into u dash minus u into v dash divided by v square. So use that formula. Here v is cos hyperbolic 2y plus cos 2x. U is sin 2x. Differentiating that with respect to x, you will get 2 cos 2x minus sin 2x, keep it as such, and differentiate the denominator with respect to x. So, the first term is y, therefore differentiation of that will give you 0 into plus cos differentiation is sin minus sin you will get. Therefore, 2 times of sin 2x you will get. Divided by v square. I think here in the problem you are having the sign changes. So this you have to consider it as minus sign. That is, we are taking capital V equal to sine 2x divided by cos hyperbolic 2y minus cos 2x. So, because differentiation of cos is minus sign, we are getting here already minus sign is there. Therefore, minus into minus will give you plus here in the differentiation. Likewise, you have to differentiate v with respect to y. So, v into u dash. U dash is differentiation of sin 2x with respect to y. Therefore, it will be a constant. So, 0 into sin 2x into differentiation of denominator cos hyperbolic 2y. Okay, differentiation is 2 sin hyperbolic 2y. We all know what is cos hyperbolic 2y. Cos hyperbolic 2y can be written as e power 2y plus e power minus 2y divided by 2. So differentiate this with respect to y. D by dx of d by dy of cos hyperbolic 2y will give you e power 2y minus e power minus 2y divided by 2, which is gives you sin hyperbolic 2y. But here we are having 2 in the power, so you have to get it as 2 into e power 2y into 2. By taking 2 outside, you will get 2 sin hyperbolic 2y. That only we are getting here. 2 sin hyperbolic 2y divided by cos hyperbolic 2y minus cos 2x the whole square. Second step is you have to take x equal to z and y equal to 0. So by putting x equal to z and y equal to 0, what is cos hyperbolic 0? Cos hyperbolic 0 is 1 and sin hyperbolic 0 is 0. Then rest of the terms we are having in terms of x only. So no need to worry about it. Now cos hyperbolic 0 gives you 1, okay, minus cos 2x. Cos 2 is z, put x equal to z and y equal to 0. Put x equal to z and y equal to 0. Therefore, you will get cos hyperbolic 2 into 0 gives you 1 minus cos 2z into 2 times of cos 2z minus sin 2z into 2 times of sin 2z. So here by putting x equal to z and y equal to 0, Vx of z comma 0, you will get it as cos hyperbolic 0 minus cos 2z into 2 cos 2z minus 2 sin square 2z. The whole thing divided by, okay, cos hyperbolic 0 minus cos 2z the whole square. So here cos hyperbolic 0, we know that it is 1 minus cos 2z into 2 cos 2z minus 2 sin square 2z divided by 1 minus cos 2z the whole square. Next, you will get it as this equal to, you can multiply this inside, therefore 2 cos 2z minus 2 cos square 2z. Here you are having 2 sin square 2z, so you can take minus sign outside, sin square 2z plus cos square 2z divided by 1 minus cos 2z the whole square. We all know sin square 2z into cos square 2z plus cos square 2z. This gives you what? Answer is 1. Therefore, you can write it as 2 into cos 2z minus 1 divided by 1 minus cos 2z the whole square. So by taking minus sign outside, you will get 1 time cos 2z, that is 1 minus cos 2z gets cancelled, and you will get minus 2 divided by 1 minus cos 2z the whole square. So what is 1 minus cos 2z whole square? You are going to further simplify it. We know that cos 2z can also be written as 1 minus 2 sine square z. So therefore 2 sine square z is going to be 1 minus cos 2 z. By using this formula, you are going to write minus 2 divided by 2 sine square z. So 2 gets cancelled, minus 1 by sine square z. What is this 1 by sine square z? It can be written as cosecant square z. So minus cosecant square z. So you are getting Vx of z comma 0 is minus cosecant square z. Now, how to find Vy of z comma 0? To find Vy of z comma 0, already Vy we already found out. So Vy you are going to find at x equal to z and y equal to 0. So put x equal to z, you will get cos 2z. This term is 0. Entire term is, first term is 0. Minus 2 times of sine hyperbolic 0 is what? 0 itself. So the numerator part, you are getting entire term as 0. Therefore, Vy of z comma 0 is going to be 0 minus 0 divided by cos hyperbolic 0 is 1 minus cos 2z the whole square. Since the numerator gives you 0, the entire function y of z comma 0 is 0 itself. Now substitute in the formula. Therefore, f of z equal to integral of Vy of z comma 0 plus I times Vx of z comma 0. This is the formula where the imaginary part of f of z is given. So substituting Vx of z comma 0 equal to minus cosecant square z plus I times integral of 0 into z. So what is integral of minus cosecant square z? Integral of minus cosecant square z is going to be cot z. So you are having f of z equal to cot z. Plus let us take the integral constant c. We know that capital F of z equal to cot z. Therefore, you are going to have, 3 plus 2y into small f of z equal to cot z plus c. So, small f of z is going to be 1 by 3 plus 2y into cot z plus c by 3 plus 2y. Now to remove the real and imaginary part, we are going to multiply and divide it by its conjugate. So you are going to have 3 minus 2y in the numerator and denominator. Here you won't have this I because you are not having I here. So you are going to have, f of z equal to 3 minus 2i into cot z divided by, a square minus b square formula. So you are going to have 9 minus, okay, minus of 4. So 9 plus 4. 9 plus 4 plus, let us take this constant term as c dash. So that's why you are having f of z equal to, okay, 3 minus 2i, because here you are having I, that's why they are getting the answer like this. But here you won't get I because the imaginary part, okay, consisting of this term formula only. So here f of z formula, after applying the formula, you will get 3 minus 2i into cot z divided by, okay, 13 plus c dash. So this is the final answer. Hope you all understood. Please kindly make a note of these things and do the problem with your fullest concentration. Thank you all.